313 is those systems of three variable equations. So like I said just a minute ago, we're going to go over that 3D grapher to come up with those graphs on that 3D grapher and see what we kind of come up with, and see if we can figure out when it comes to two planes what makes them parallel, and when they do intersect, where they intersect. Sound good for you guys? Alright. So we are going to, actually I think I'm going to do it this way. Alright, so on 313, those systems of three variables, if you guys know how to get here, right? We're in chapter 3, 313, and we're going to look at this problem 630, three-dimensional systems of equations. So we're going to look at these two systems, and we know that it's a system. Oh, I think I can use my pointer. A system is where you have two or more equations, right? So we're going to focus on this first system, and we're going to put this into our 3D plotter, and then we're going to turn around and come up with have a little discussion and see what we notice and why we notice it. And then we're going to plot this second system, and then when we plot that second system, come up with a little knowledge from that as well. Sound good? I hope so, because all I see is the CPM textbook on my screen. I don't see you guys. So you'll have to yell at me if you don't see it, or if we got issues. So right online, it even gives you that little 3D plotter. So we're going to click on that. All right. And this little guy is going to pop up, and we talked about this little plotter yesterday, where this one, if we wanted to just plot a point, it'll give us that point in 3 dimensions, and we have those equations, so we're going to click on our little equation guy. All right. So if we click on that, then it gives us that parent one, and if we click on that equation, then it allows us to change those coefficients in the front. So to help you guys out, because that's no longer on your screen, in front of the x, our a coordinate was 20. Our b was 12. Our z was 15. And d, what it equals, was 60. Okay. And everybody's got that in there, right? And then it's a system, so we need another equation. So if we click on that x plus y plus z little button again, it'll give us a second equation. And those colors are a little too close. So I'm going to click on the color. Let's go red and blue. I'm going to go red and blue. I like red and blue. And if we click on that equation, then we can put in all of our coefficients. So a was 20. B was 12, C was 15, and D, what it equaled, was 120. So I'll give you guys a minute to get that all plugged in. All right. So then now you guys can use your touchpad. And remember, if you put your mouse on here or your touchpad, you can move this all around, right? So I want you guys to start moving this guy all around and tell me what you notice about these two planes.
You had a couple that said they're parallel.
Hey, good job. Yeah, they're parallel, right? So no different than in lines where we can have parallel lines, we can also have parallel planes. So we know that these planes go on and on forever, and they never end, and then on these ones they never intersect, right? So they are parallel. So if we actually look at our two equations, we got to try and figure out like why they are parallel. Anybody got any ideas? What do you notice that's the same, or what's different?
Good you go. What about, somebody said X, Y, and Z. What about X, Y, and Z?
Yeah, what about X, Y, and Z? What do you notice? Those things in front are called those coefficients, right? and our coefficients are all the same, right? So in our notes, switching back over to this guy, so we can sit there and talk about parallel planes, right? So if we write down those two equations, that system that we were looking at, they were, what was it, 20x plus 12y plus 15z equaled 60. And then the second one was 20x plus 12y plus 15z equaled 120. So in order for these guys to be parallel, those coefficients all had to be equal, right? They had to be the same. And it's not just, if we go back to our graph, there's so many things open on my screen. There. If I just changed one of these, so if I think of the blue plane where my A was 20, and if I change that to, I don't know, give me a number, any number besides 20. 7. You guys always pick 7. So on this one, it's going to be hard to see because it's going to have a little bit of a slant to it. We're going to just jump it up to, oh wait, I think I got to hit enter. There we go. If I hit enter, it'll work. So if I just changed one of those, look what happened. What happened to those two planes? They now intersect, don't they? So even though my y's and my z's were the same and my x was different, it's still going to cross someplace. So the only way in which they are parallel is if all three of those, that x, y, and z, those coefficients, those numbers out front are the same. Now what it equals, that d value, that doesn't matter because that's really just however you want to kind of think about it, I guess. If we were to turn it, right? It's almost kind of, you know, the distance that they are away from each other. One's at a 60 and the other one's at 120. So, quote unquote, there's a distance between them, and that's the difference between like that 60 and that 120 is how far apart they are from each other, right? All right. So I think we're good on parallel planes. So we're gonna spice this up a little bit. And we're going to look at that another system. We're going to keep that top equation exactly the same that it was previously. But now I'm going to change all of the coefficients on that second equation. And I don't know, let's go with a 10x plus 30y plus 12z. But now I'm going to say that that equals 60. So now what they equal is going to be the same. My coefficients are not going to match up, but my D is going to be the same. Anybody got any ideas what they might want to make a prediction about what's going to happen when I graph this?
They're probably going to cross.
They're probably going to cross. All right, let's try it, right? So we have what? We got a 10. Our coefficient in front of y, what did we say was 30? You guys are doing this too on your computer, right? Yes, Mrs. Fitch, we are. Good job. Right, and I put in my 60. And look at that, you guys were right. They did. They intersected, didn't they? Very nice. So let's go back a little bit and think about when we graphed lines. If we took two lines and those two lines intersected, they intersected at a, starts with a P, at a point, right? So take a few moments to sit there and spin this guy around and see if you can figure out what happens when these two planes intersect. What do they intersect at a? What would that shape be called, or that? And sometimes you can get it to line up just right, and it kind of helps you a little bit. Okay. Yeah, it's a line. That little blue mark going through, that's that other plane, right? and it's intersecting, and if you get it turned just right, you can almost see it where it's a line. So two planes intersect at a line. I don't know if you guys, can you guys like see me or no? Yeah, kind of. All right. So one thing that I kind of help, like if you think of a sheet of paper, like a sheet of paper is like a plane, right? If I fold my sheet of paper anywhere, I can fold it anywhere I want, right? Fold it there. And I'm going to kind of like use my imagination, and I'm going to, when I open it up, I'm going to say like I have two planes. Like this part of my paper is one plane that's going to keep going, and then this is like another sheet of plane that's coming down, right? So like it would kind of, you know, look like this and like this. Well, when I folded my piece of paper, what did my fold make? My fold makes a line. Good job. Yeah. Yep. So we now know that when it comes to two planes, they intersect at a line. Did that 60 have anything to do with anything when it came to our graph? Even though it was the same, did it change anything? No. Right? Because even if it was 60, they're still going to intersect because the x, y, and z coordinates are different. If I even change this back to 120, guess what? Those planes are still going to intersect, and they're going to intersect at a line, right? So in our notes, we need to make sure that we have that written somewhere to where then if my coefficients are different, and it doesn't matter, only one of these could be different. Like if I were to change, oops, that's not my eraser. If I were to change this guy and this guy, if I were to change this back to that 12 and that 15, do you think they're going to be parallel? No, because my x's are different, right? So it only takes one of those to be different, and if any one of those are different from the other, then they're not going to be parallel, right? So if any coefficient x, y, or z are different, then the planes intersect. And they intersect, well, we'll just put it right. Oops. It would be a line, right? So we gotta know that those babies intersect at a line. You guys good with that? So, yeah. So we know how CPM kind of works. So CPM just kind of sprinkles this in a little bit to kind of get you guys thinking about the planes and how they intersect and that X, Y, and Z and that whole three-dimensional. And then when it comes to your guys' review and preview, they're not going to give you a whole lot when it comes to graphing the three dimensions. They're going to have you go back through and work on systems of equations and factoring, because that might be something that we're going to need here shortly when it comes to doing three-dimensionals. Right? So I got a couple examples to go over you with that review and preview. So do you guys remember how to go from exponential to logarithms? We just kind of finished that unit up, right? So if I want to go from exponentials to logarithms or the other way around. Some of us do it a little bit differently, but if we had a base raised to an exponent that equals a number, right? And then if we wanted to make that into a logarithm, it would be log base b of that number equals the exponent, right? Some of us use x's and y's. You can use whatever letters you want to use in there, right? The other part to remember, if they want you just to find out like what the log of 23 is, and we notice that there's no little base that they put in the problem. So if they don't write the base, we automatically assume that that is log base what? 10. Yep, log base 10, right? So if you need to, write that little 10 in there, right? So just remember that we're in a base 10 system, so we get lazy sometimes in mathematics, and for those logarithms, if there's no base, it's always going to be a base 10. Good to go? Alright, I got another one for you. They gave you guys a whole bunch of stuff today. Remember inequalities? Right? And do you remember how to write the equation of an inequality? Sort of, right? So, in your review and preview, I think I got it on here, still up. Whoops, oh, I just closed it. Way to go, miss. One of these days I'll know what I'm doing. There we go. They have you guys doing a system of inequalities. See how they're bringing in those systems? So, in a system is just two or more equations, right? So, I just put one up here just for us to remember how to do this. So we got to kind of come up with that equation of the line, and then we got to figure out how our inequality is going to work. So you guys like slope-intercept form? Can we write this equation of the line? So if we thought of y equals mx plus b, we know it's going to turn into an inequality, so I'm going to skip the equal sign. All right. Let's start with the y-intercept. What's our y-intercept going to be? 3. All right, positive 3, so we know that that's plus 3. We know we got an x, so I'm going to fill that in. And then we just got to figure out our slope. And hopefully, I tried to draw it really carefully. That's why I did it ahead of time, so it wasn't too sloppy, right? So I usually just go from my intercept, and I try to find another point. Oh, look, right there's one. So what's my slope from that point to that point? 1 over 2. Good job. Yep. So we got 1 over 2. So that gives us, I'm going to clean it up. Woo. So we had y 1/2 x plus 3. So now we just need to figure out our inequality. This one's a dotted line or a dashed line. So that tells us that it cannot equal. So we're either going to have a greater than or a less than symbol, right? So a greater than or a less than symbol. So usually what I do is I just go right to that y. Oops, don't erase. I usually just go right to where that y-intercept is, if I can hold it straight. And then I'm shaded below, so my y values have to be less than my line, right? Because I want to go below the line. So my y has to be less than. So less than. And I lost my 3, right? And we can't put that equal sign underneath because it's not a solid line. You guys remember all that good stuff? Right? So then when it comes to the system of equations, like on that problem, so you got to find the equation of this line, figure out if that's going to be greater than or less than, equal or not equal, and then you got to do the same thing with that other line, right? So you're doing it twice for 2 different lines. You good with those? All right. Simplifying. So we're going to simplify some radicals or some rational expressions. So let's say we have, how about a 3x squared minus 10x minus 8 divided by 3x plus, I'm starting to think I've used this pen too much and I need a new tip. 3x plus 2 times, let's go 5 over x squared minus 5x plus 4. So on this one, they just want us to simplify because it's not an equation, so it's not equal to anything. So we can't find out what x is going to equal because we have no equal sign whatsoever. But we can simplify this, and we can simplify it by finding our factors, right? So we know good and well, like we cannot cross these 3's out. We cannot cross these x's out, right? they have to be factors in order to cancel out. And factors are things that we multiply. So we need to go through and see if we can factor all of these different guys, right? So I know you guys are becoming factor experts, right? So I'm going to do this one using the area model. And I'm going to do this one by just using like the FOIL or just getting right into the factors, right? So if we do our area model, right, you got your little area of a square or a rectangle. You're all right. So I got 3x squared. I'm trying to figure out how to break my x up, right? Literally, that was cute. See, that was my joke. Break my x up because, you know, they're my x. I'm mad at them, right? And then my -8. So I got to figure out how I'm going to get -10. I got to split that into two different x's. So, and because I know that it's, when I multiply, I'm getting that negative number. I know that one of these x's has to be positive and one of them has to be negative, right? So the only way I can multiply to get a negative number is by having opposite signs. So 3 times 8 gives me that 24. I'm going to write it down here. So my factors of 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And for me, my signs are opposite, so I got to find the difference between my factors that are going to give me a 10. So which one of these four, if I do the difference of them, is going to give me 10?
Okay, 2 and 12.
2 and 12, right? Yep. And which one's going to be negative? The 2 or the 12?
The 12.
The 12. Good job. And then I got my 2, right? So then now I'm going to pull out those common factors, right? So I'm just going to start at the top. So between these guys, I can pull out a 3x in common, right? This would be a positive 2. Going horizontally, this guy's going to give me an x, and this one's going to give me a -4. Right? This is all a little refresher for all of you guys, right? Everybody's good with these. All right. So this numerator, I can rewrite that as 3x plus 2 and x minus 4. When I look at this denominator, can I factor that at all? No. So I'm going to write that as 3x plus 2. And I'm going to leave everything before I cancel anything out, right? Times my second fraction. I can't do anything with the 5, so I'm going to leave the 5. And then I'm going to try and factor this guy and see if he's factorable, right? So I'm going to jump on this one and just write these as my two factors. In order to get x squared, and I have x times x. When I multiply these guys together, I'm getting a positive 4. So the only way I can get positive numbers is if I multiply two signs that are the same. So either positive, positive, or negative, negative. That's telling me it's going to be negative, negative. Then when I multiply, I get 4. And the difference has got to be 5. So we know it's going to be a -4 and a +1, right? Now I look to see if I can cancel anything out, right? So, and if it makes you warm and fuzzy, you can throw this guy in the bottom in parentheses too. Right? So they have to match up perfectly, and they got to be multiplied, right? Because these are technically being multiplied together. So I think I can cancel 3x plus 2 and 3x plus 2. X minus 4 and x minus 4. What am I left with in my numerator? And what am I left in my denominator? Look at you guys. Yep. Sweet. Right? And then I know in the past we've talked about those excluded values. We know that our denominators can never equal 0, right? So if you wanted to find those excluded values, you would set these guys equal to 0 and find out what they cannot be, right? You good on those? All right. I got one last one for you. So instead of simplifying, they might ask us to actually solve. Right? We're going to solve all the world's problems. So they might give you this nasty problem. Let's go with, I don't know, 2x minus 5, and then x plus 6 squared, 3x plus 1, and they say this whole entire thing equals 0. You would think by now I could write in a straight line, wouldn't you? I even put dots on the paper. 2x minus 5, x plus 6 squared, and 3x plus 1 equals 0, right? So we learned this little property way back in the day, and it was called the zero product property, right? And so the zero product property, ultimate product is multiplying. So if you're multiplying products together, you're multiplying factors together, and you want it to equal 0, one of those products, at least one of them, has to equal 0, right? So these factors are all being multiplied. So either this guy's got to equal 0, this guy's got to equal 0, or this guy's got to equal 0, right? So then we're just going to split it up and set them all equal to 0. So either 2x minus 5 has to equal 0, or, well, there it goes again. And then it's like it doesn't even want to respond. Or x plus 6 squared's got to equal 0, or that 3x plus 1's got to equal 0, right? And then now we're just going to do algebra to solve it for that x. So we're going to get what? 2x equals 5, x equals 5 over 2. We're all good with that, right? On the second one, you guys got a couple options. You can take like the square root of both sides, or anytime something is squared, it is multiplied by itself. So if you wanted to, you could even write it as x plus 6 equals 0 and x plus 6 equals 0, which is going to give us x equals negative 6, and this one's going to be the same thing. Right? And then on the last one, you're going to what? Subtract 1 and then divide by 3. Okay. And technically all 4 of those are your answers. You could even kind of check if you count up the powers. Like there's technically a 1 here and a 1 here. So you'd have 1, 2, 3, 4. So it's a 4th degree polynomial, and since it's a 4th, like at most you could have is 4 answers, and we found all 4 of them.